Hello everyone. Welcome back. Today we'll be tackling problem number 6 for day 1, and it is LeetCode 209 minimum size subarray sum. And the problem statement goes like, we have been given an array of positive integers. Remember, we just have positive integers and the name of array is nums, and we have also been given a integer named target. We have to return the minimal length of a subarray whose sum is greater than or equal to a target. But if there is no such subarray, we need to return 0 instead. Okay, so this is the example. We have a target of 7 and we have been given an array, and the output is 2 because 3 is the length, which is the minimal length of the subarray, which equates to target. Okay, let us move to the dashboard and we'll try to tackle and investigate this problem and arrive at its solution. Okay, so we have been given this array and we have been given a target variable. Now, how do we solve this problem? The question states that we have to determine the minimal length of the subarray, okay? Minimal length of the subarray whose sum is greater than or equal to target. What could be the brute force way? The brute force way would be to generate all the subarrays and to compute their sum and then determine the length of the subarray where the sum exceeds or is equivalent to target, okay? And then compare all those lengths and find the minimal among all those lengths, right? But this investigation of generating all those subarrays will take us order of quadratic time, and comparing the lengths will take again order of like linear time, right? Comparing lengths as in we have to compute the sum as well, right? So yeah, but we cannot take that path. We have to avoid the path of quadratic time. And every time, more often than not, every time we are encountered with a problem based on Subarray, our first thought should be towards sliding window. Okay. So, and in fact, for this problem, sliding window is an optimal approach, and we'll investigate and solve this problem using sliding window. What is the prerequisite for sliding window? We need to have two pointer, left and right, and we extend our window in generally towards right using right pointer. Left pointer moves if and only if, or only if when we have a violation in our condition, or when we have to reach certain state. Only then we move the left pointer. Otherwise, we keep on moving our right pointer. Now let me walk you through this code, how we'll solve this problem. The problem asks us to find a subarray, okay, and it also gives us a condition that the sum of the entire subarray, it must be greater than or equivalent to target, right? Suppose we form a subarray. Like let me start from this point, okay? We maintain a separate variable. Let me call it current sum. When I am at this position at 0 index, so what will be the current sum? It is 2, correct? Is it greater than 7? It is not, right? So what we do, I move my right pointer to the next part. I add the sum to it. Now it becomes 5. It is still not greater than 7, so I move the right pointer again. It becomes 6. It is still not greater than 7. I again move the right pointer here, and it becomes 8, right? Now it becomes greater than or equivalent to 7, which is the target, right? We see in this case that our condition has been either violated or it has been succeeded, and we are trying to reach a state now. What is the state we are trying to reach? The state we are trying to reach is we are trying to minimize the length of the window that has already given us this condition. In this case, what is the current length? The current length is these characters, right? 5. How do we minimize it? Whenever we talk about minimizing or reaching certain state in sliding window, what do? We move the left pointer. Okay. But before moving the left pointer, let us see what will happen if we move the left pointer. Currently, our window is up to this much, right? And the sum accumulated is this 8, correct? If we move the left pointer 1 ahead, 2 will be discarded, right? But that needs to be carried away in the sum as well, correct? So in order to accomplish that and in order to accommodate with that, what I do is I will subtract 2 from 8, okay? And my result will be 6. And once I do that, I can easily move my left pointer and bring it here. Is 6 greater or equivalent to 7? It is not, right? So what I do, I move my right pointer again. The sum becomes 10. Is it greater than or equivalent to 7? It is. So in that case, what do? I move the left pointer. ahead, but before moving, let me subtract 3 just to maintain the sanity. Once I do that, it becomes 7. Is 7 greater than or equal to 7? Yeah, it is. So left pointer comes here. I can still move it 1 ahead. Before I do that, 7 will become 6. Why? Because 1 will be subtracted, right? Is 6 greater than or equal to 7? It is not. So left pointer is here, right? Now we have the current window is this, right? Let me change the color. The current window is this, right? 2 and 4. I move the right pointer once again and it comes to 3. Now the sum of 6, it will become 9. Is it greater than 7? Yeah, it is. So let me move the left pointer 1 ahead. As I do that, 2 will be subtracted from 9. It will become what? It will become 7 is greater than 7. And the current window is 4, 3. What is the length of this window? The length is 7. The length is 2, but the sum is 7, right? Which is this, and the length is 2, right? So among all those subarrays that we have checked right now, the minimal length is this one, right? Exactly that is what has been done in the code here. We have maintained a left pointer. The right pointer is over here, which is acting as an iterator within the loop. And the loop will span across all the elements of the nums, which will take order of n time. We also have a current sum as we had here. And we also have minimum length, right? This is the length of the window, and we have to make sure that the subarray that we have achieved has the minimal length. Initially, I have initialized it to infinity. Okay. Now, inside loop, the first thing that I will do is within the current sum, I will add the right pointer value. Okay. And I'll check for a condition, which is an important condition here. I will check if the current sum is greater than or equal or equivalent to target, which was given in the question. And if the left pointer and right pointer are within the bound of each other, as in left pointer is less than or equivalent to right pointer, in that case, I will come within the loop. I will compare the minimal length, right minus left plus 1, or minimal length. And then what I will do once that is computed, our objective now is, since we have achieved this window, and since the sum that this window gave us, since it exceeded the target sum, now what we are trying to do is we are trying to shrink the window from left. So we will discard left, right? So that is what we are doing but before discarding, what I am doing over here is I am chunking out, or scalping the element from the net sum, which was at the left pointer, right? And then I move my left pointer once that has been chunked out or scalped out, right? And left pointer has been moved right. And this will go on and on and on until we achieve the minimum length, until and unless this condition do not state to false. This loop will keep on running, and at one point we will come out of this while loop and we'll go back to this for loop, and this condition will and this whole operations will go on until we exhaust the entire element of the nums, which will take me order of n time over here. And in worst case, uh, what is the time complexity this will take me? Less than or equivalent to order of n, okay? So more or less, it is like a product of two values. The time complexity is like order of n times order of, let me say, some other factor, okay? And this will be less than order of quadratic, all right? And at the end, we return minimum length. The question states that if there is no such subarray, then we return 0 instead, okay? We check for this condition accordingly, and we return either 0 or the minimum length as we have achieved over here, right? So this was the basic analysis of this problem and how we approach this problem, right? So this was the code, this was the basic analysis, these are the time complexity and space complexity. For a more detailed and intricate time complexity, you can look at this part, okay? And yeah, that's it about this problem. Let us move back to LeetCode dashboard and we'll try to submit this problem and see how it goes. So we are at the dashboard. I have already solved this problem for you. I will just try to paste my solution and run this code. And I think it will run and the test cases will be accepted. As you can see, it runs and the test cases has been accepted. Okay. So yeah, it was frankly an easier problem than all the problems we've encountered in the past today. But I hope you are now getting a gist of how we are trying to solve problems based on sliding window, especially how the pointer should move, left pointer and right pointer, why right pointer should move towards right only, and when left pointer should move right. So yeah, as far as are there any edge cases that we need to be worried about in this problem? Um, Not really. Like one of the edge cases that we need to check is whether the array is empty or not, right? But again, that is something which is not given this problem because our arrays will always have a value. Okay, so yeah, that's it for today's problem. I will see you in the next problem. Bye bye. Take care.